Okay, for section 10.1, problem number 2, they ask us to determine if the graph is a graph of a one-to-one function. Determine if the graph is a graph of a one-to-one function. So, problem number 2. How can we tell if it's a graph of a one-to-one function? First of all, it has to be a function, so it has to pass the vertical line test. If we have a graph, we can just kind of visually go up and down all over. Does it hit anywhere twice? No. Or more than twice? No. So that's a function. It also, in order to be one-to-one, it also has to pass a horizontal line test, and this one does. So it is a function, and it's one-to-one. Problem number 4 says if it's a one-to-one function, have us find the inverse. This is a one-to-one function. How do I know that? Well, you'll know it too when you know what the graphs look like, but the cube root graph looks like this. So that might be shifted over, it might be skinnier, or whatever, but it is a one-to-one function. See, that passes the vertical and the horizontal line test. So let's find its inverse algebraically. First we're going to replace the f of x with y. So we're just rewriting it. Boom, nothing. The next thing that we do is we're going to interchange the x and the y. The inverses interchange our x with our y and our y with our x. Our domain becomes our range and our range becomes our domain. So we're just going to rewrite it this way. And then we're going to solve for y. Because this is written f of x, so this has replaced our y with an f of x. We want to replace our inverse function with f inverse of x, so that it's in terms of x. So in order to liberate the y here, I'm going to cube both sides of this equation. I have x cubed equals 6y minus 4. That gives me x cubed plus 4 equals 6y. Divide both sides by 6, and I have y equals x cubed plus 4 over 6. And then, now that I have solved for y, I just replace that y with f inverse of x equals x to the third plus 4 divided by 6. That's your final answer. Okay, problem number 6. Problem number 6, they give us a... Uh-oh, I lost my page. Problem number 6, they give us this graph, or this table. Right here. It says the table lists caffeine amounts in several popular 12-ounce sodas. If the set of sodas is the domain and the set of caffeine amounts is the range of the function consisting of the 6 pairs of letters, is it a one-to-one function? So what we have is a thing right here, and we have Mountain Dew, we have Diet Coke, we have Dr. Pepper, we have Sunkist, we have Diet Pepsi, and we have Coca-Cola. All right, and they give us numbers, 55, 45, 41, 41. I wonder if these are real, 36 and 34. All right, so the question is it a one-to-one function? First of all, it's a function because none of these parts of our domain repeat. Okay, so Diet Coke isn't 45, and then Diet Coke is also 41. However, it's not one-to-one because 41 shows up in our range twice. So in a one-to-one function, not only does every x have to be unique, every y has to be unique. So this is not one-to-one because of those right there. So problem number 8. They've given us a graph for problem number 8. And what's especially important to note is that they've really been obvious about these ordered pairs right here. This one right here and this one right here. Okay, so we have a little curve like this. So if this is our function, let's call this f of x. It is one-to-one because it also passes the horizontal line test. We don't have to do anything complicated. These two ordered pairs we know. This is 0, 1, and this is 1, 2. All I need to know is that my inverse function has exactly the opposite. The x becomes the y becomes the x. So I know that in my inverse function, I'm going to have a 1, 0. Okay, those are going to reverse each other. And then I'm also going to have a 2, 1. Now the other thing is that when you're drawing your graph, you should think about the diagonal right here. This is the line y equals x. And our graph should be reflected around it, across it like that. Okay, so see, this should be mirror images of each other around that diagonal. If they intersect, they would intersect on that diagonal of y equals x. So that's problem number 8.